G'day, this is Dazamoto Games. This is a follow-up to my previous video on making the character swap animation. I'd actually coded it to work earlier, but I realised that my code wouldn't work for multiple game modes, which is a big feature that I want to implement in the near future, and so I spent the last couple of days rewriting it. Without further ado, let's take a gander. So first of all, when can the player switch characters? When standing still. This makes it a deliberate choice. It suits the animation I made better, and also saves me a lot of work. Let's check out the idle state. The character swap check is at the very bottom of the physics update process, and that's because it's probably the last thing that you'll do if you're standing still. So if you click the swap character button, let's follow the code here. In this function, we're going to check if we can swap the character. The reason we're checking that is because there is a gauge that you need to fill up before you're able to swap. If that is true, then we're going to transition to a swap character state, and we're going to send in a callback signal for when that swap state has sort of finished its animation. So let's go ahead there now. Now this state machine is different from the one that I showed you in my previous video for my enemies. This state machine is based off one that was built by guys over at GD Quest, and I really like that state machine because it sort of encompasses all the states in a node like this, and it really makes it easier to sort of wrap your head around it. So when this state is called, we're pulling in the callback signal, and we're going to store that on the state here. And we're also going to turn off the plate hitboxes because we don't want to be hit during the animation, because that'll look weird. The animation is quick enough so that if you use it in a bad spot, when your next character will come in, they'll probably die straight away. We just do a quick check if the swap animation exists, and if it does, then we connect to the finished signal, okay, and then we run the animation. Here's the on swap animation finished. Here we're just setting the animation back to idle, and this is to ensure there's no flicker and the animation changes when the node is removed from the tree. That's supposed to go there, isn't it? This is, we allow the player to die again because the swap animation is finished. This will automatically take us out of this state and brings back to idle, but what will happen is this callback will be run straight away after that, and you won't see this happen. This is important for when that node eventually comes back into play, because we don't want it to be coming back in this state. Here's the callback signal, and that's going to run the swapped character signal, which is on the player. There it is. Where does this go? I'll show you now. This is Dazza from the future. While this video was in production, I've since implemented more game mode functionality, and this part of the code had to be redone. I think you can probably tell what has caused it by now. Anyway, most of the conceptual stuff is the same, but instead of reusing nodes by removing and adding them to the tree, I'm freeing them and instantiating new ones. This ironically really simplified the logic and made it much more flexible. So if we look at the first function here, we've got spawn player character, and then this checks if the character is coming into the start position, otherwise it comes in such as when we're swapping. Here we instantiate the new character and we set its position and direction. We also set the camera and also the save data this player will be referring to. And now the save data is in one place, and so it's consistent across all the different systems. And here we add the new node to the tree. This I'll probably talk about in the original video, but this prevents the sprite from flickering. We set out some signals, and then here, if we're running single player, we will sign up to this signal, and because this will be, let's say, when we swap characters, we are freeing and instantiating a new one, we can safely connect one shot and not have to worry about it. The swap happens in this function here. Right, here we're getting the outgoing character, and that is bound to the swap character signal call here. We get the other character alias. Make sure we store the previous direction and position of the other character, and then we can load in the new node using the aforementioned function here. And this is great because it can be used for swapping, and it can also be used for spawning the player character in at the beginning of a level. Now of course, the outgoing character is freed. I have a function that applies horizontal flip to the sprite. If I didn't have this, there is a slight flicker when the node comes in. It updates the correct direction, but there is like a frame where the character is in the previous X direction and it doesn't flip over. But by adding this here, the character comes in and it's nice and smooth, you can't tell. any difference. This took a really long time to find and debug, I tell you what. And that's how it works. Let's just go back to the jungle and have a look at it again. As you can see, you can hardly tell that is switching out. Okay, and that is everything. Obviously, I still haven't done the animation to swap back from Utrecht to Olivia, but you know, that'll be done in short order, and I'll probably upload another sprite time lapse of that. But anyway, thank you very much for watching. Like and subscribe, and I'll see you next time.